Good day, everyone, and welcome to today's class. This is example 2 on vector algebra. This is a question a very simple way. We are still working on cross products of vectors or the product or vector product rather. So now we have this question here. It says if P is equal to 2I minus 3J plus 4K, and we have Q equal to 5I minus 4J minus 3K. You are asked to find the vector products of P and Q. B says find the magnitude of the vector product. This stands for magnitude. Okay. Remember, I always tell you we have two major products in vector algebra. We have dot product. Dot product is like this. Then we have a normal vector product, which is also known as cross products, and both of them have different formulas. Okay, so we are going to be concentrating on this. This is the one that has to do with this question. Mean that our solution. Okay, our solution. Our vector products, normal vector products or cross products, is given by what? We are going to write these elements in an array. That means in a matrix form, taking the components I, we have J, we have K. Okay, so the next thing we are going to look at, you check the elements here, the coefficient of this component here, which is 2. For vector P, we have 2. Here we have a -3. -3. Here we have a +4. Then let's go to Q. We have a 5. Then we have a -4 and -3. So automatically you have formed an array, and this is now in a matrix form, meaning that we are going to use determinants to find these products. So it means A times B. So we're going to find here. So what you need to do now, I am going to take this one as a principal row that will multiply the corresponding elements. So what do we need to do? I am going to make use of this sign that says plus, minus, plus. So since I am taking from the first row, I'm going to make use of this. If I take it from the second row, it's going to be negative plus negative. Alright. So now let us go over to this place. I'll finish it up. Okay. Now, if I take this I, mean that in my first, that is I, I'm going to have a matrix that will multiply here. So now, you don't take element from the column where that I is located, and also on that row, in that row where that element here, this I is located. So you take like this now, like this. Okay, it becomes -3 and -4 here, -3, -4. Then we have 4 and -3, 4 and -3. Then you move to -j now, because I am using this sign. -j, we have to also multiply another one. Look at the column here. This one is covered, then you cover there. So we have 2 and 5. 2, 5. Then here we have 4 and -3. 4 and -3. Then the next one is plus K. K will take its own matrix. Alright. K here, you cover this column, cover this row. You're going to have 2 and 5, then -3 and -4. Here we have 2, 5, -3, -4. So let's minimize the board. So that's what we have there. Now let's go. In our determinants, what you do now, you have to take the principal diagonal, the product of this principal diagonal, then minus the product of this other diagonal. So now let's go. -3 times this is +9. So your I, we have 9. -4 times this is -16. Because of that minus, we got plus 16. Alright. Here we have a -j. Now multiplying these 2 times this -3, this was -6. Then minus 5 times 4 is 20. Okay. Then we have a plus K into this. 2 times negative 4 is what? Negative 8. Then 5 times 3 is what? This is negative 3 here, becomes a negative 15. Now minus that negative 15 gives you what? Plus 15. Okay, because of that negative. So now we can have this plus this, it will give us what? 25 I. Okay, then minus this and this becomes what? Minus and minus. This one is already inside here, become minus 26. Because of this minus, I say become plus 26j. Okay, here we have a minus 8 and plus 15 here. Then this will become what? Plus 7k. So this is our vector product. Our vector product now is equal to 25i plus 26j plus 7k. This is your answer to A. Alright. The answer to this B now simply means I will have to square each of them. So the magnitude of any vector is, this is the magnitude now, that is the B, is equal to the square root of A times B. That is the square root of the square. Now, this is the formula for calculating the magnitude. The square root of the square of what this product that we just have. So if it's just a single vector, so you have to square the respective elements. Then you find the square root of their addition. So here, your A times B magnitude now, the product magnitude will become the square of 25 squared plus 26 squared plus 7 squared becomes 625 plus 676 plus 49. Okay, so at the end of the day, the final answer becomes square root of what? 1350. That is your magnitude of the vector product. So this is the final answer. So that is the final answer, square root of 1350. So if you find this class very interesting, please do not hesitate to share this video, and also do well to subscribe to my YouTube channel, Physics and Mathematics Lovers. Bye.